小さい。はい。全体を見る。はい。So this is my project called Internet Distance. So what I did is I'm pedaling to Montreal because I was waiting 2 years to go to Montreal, but I couldn't. So I started pedaling to go to Montreal. So this is my route. So we are here in Japan. So I go to the airport first, then go to Vancouver. Then I'm still here near Calgary, but I'm sure I can go to Montreal during the half 16. So this is how it works. So I bought fitness bike. The fitness bike has a magnet and hold sensor inside. So if I pedal once, the magnet sensor count 1 to send the signal to the display controller here. So I use CD in shell. It's a very small controller board. It's based on SAMD 21, but it's very powerful, cheap and powerful. So I got the signal from the fitness bike. Then I add some buttons, and I program as a human interface device. So when I pedal, the shell receives the signal, then shell acts like a keyboard. So shell send a signal, keyboard signal going upward to the computer. In the computer, I open the Google Maps, Street View, or Google Earth. Then we can go forward, and we can turn right and left, anything we can program. So this, I don't have the bicycle here, but this is actual actual boards, control and boards like this. And this is video. I think I can see. This is on the street view. I think it's Vancouver. And the next one is Google Earth. So I can fly it, I can go anywhere. But it's quite difficult where I am. So, and the next, how to
Excuse me, question.
Yes.
What kind of the signal or information is coming from the fitness bike? The pulse or the speed, analog speed?
It's also analog. I think the whole sensor should be just pulse, is it?
Yeah. So I think the originally it is pulse from the whole sensor with the magnet.
Good.
And the pulse itself is sent to Arduino, or the pulse is converted to some kind of the speed information, then sent to Arduino.
No. If you see here, okay. There is only whole sensor inside.
I see.
I think so.
Then
the cable goes to the microcontroller in the screen box. So I separate the signals before the controller. So I think it's only the whole sensor's very simple signal.
I see. Okay. Thank you.
Yeah, I think so. How to make both? Okay. So I have here. So this is my controller. Whole sensor signal come to this part. Come to this part by the monaural jacks from like audio. And I put the this pin jack to the display controller. I just separate the signal in between this terminal from this jacket.
Okay.
You can't see, you can hear, you can see the schematic and boards layout. Yeah, you can imagine, I think so. This is the old one. So now I use this version 2.
Okay, thank you.
Okay. And how to program. So this is a program of the. It's not good. Maybe wait a minute. Controller one make. Okay, this is better. So this is how to make controller one, which I use now. So it's costs not so much. The CD in shell is only $5.4, and I have some socket and button only. It's very simple. So this is inside. I use the cable between controller and the board. The schematic. The board. So for the program, I use this library, a tiny USB mouse and keyboard. So this library is very convenient to program the HID device. I wanted to use tiny USB, but it's quite complicated. I so far give up to use it. So if you use this one, so you can program very easy. So I'll show you some parts. Okay, so here, so this is keyboard parts. Key access. Okay. If keyboard press, which means a button is pressed or whole sensor signals on, Arduino runs this function. So this is the from library keyboard press, and you can write any key you want. So this is an example of the pressing right arrow key on your keyboard. It works same as the keyboard. And for the up arrow. So it's same as here. Then if you need press more than 2 keys at once, this is about keyboard press and the key left GUI. I'm using Mac, so left GUI is left command button. So if you are using Windows, you may write right key control or something. And you press the command button here and command the Alt key option button, then press right arrow, then release all, which means two function key and 1 arrow button press at the same time. And this is another one. So if you need write the character key, so press command key first, then just write keyboard right and any key you want. Like this is L. So command and L means one of the shortcut of the Chrome browser. And keyboard shortcuts. I use CD in Shao because Shao has a lot of functions to easy to use. So one of this is QTouch. QTouch is one of the capacitive sensor. So you can make touch sensor easily. So you don't need any tactical button or something. So this is pin out of the shell. You can see the yellow parts, the QT. So shell has 1, 2, 3, 4, 5, 6, 7 touch keys. Q touch keys. So if you see the schematic, I have only shell and the bytes input and output, and this pinhead only. I wrote the schematic. I wrote the keypad on the schematic on the board. So this is a real one. So just so I had a 4 arrow and 3 buttons. So totally 7 key. It works easily. And so this is a program. So to use the QTouch, so you use the library of Adafruit free touch. So it gives some function. So you write like this, Adafruit free touch, and put some parameters here. The QTouch begin. And this is the same as the this one. So if QTouch is more than this value, So it means it's pressed. So key to act is will be work. The key to act is this key button, key down button, and LED blink. It works like this. Almost PC software has a shortcut. So I put some link here. So if I see Google Map, you'll find find okay, different one. Okay. So this is the example of the Google Earth. So you can use this character and some combination of the keys you can control from the keyboard. So as a workshop, what I want you to do is make a QTouch keyboards program. You may not have Shao now. Do you have Shao? No. Okay.
No.
Yeah, I understand. So I just want to think about the idea how to use QTouch QTouch function to control the computer by using shortcut key. So if you give us your program, we can run in our shell here. So you can see the result of your program. So I always use the Google Map and the Google Earth. So I'll give you another example from us as a person. So Sorry, wait a minute. Hmm? 全体はどれでしたっけ？ベーシック、ウィンドウでも多分これが来る。まさにいいですかね。はい。はい。これです。音声出ます。音声出るのかな。あれで、多分画面共有の時に選ばないといけないです。これか。違う。これに立ち上げて、こうして、ここか。Can you see that? Something shiny,
Yes, I can see that.
maybe. はい。
I see, I see. Sensing,
So
sensing system.
this is the through at Kanai, and so by making foot map controller, I made some game controller that I can use foot as a player's touch. So please watch the video. So this is the actual circuit, and I assign some keys, and then I can do Dance Dance Revolution. So this is a very famous computer game in Japan. Because we can use a shell and a Q-touch sensor as a key, and this is an internet version of the Dance Dance Revolution. So you can make this kind of game controller easily by using shell. And as I used some aluminum foil and some of the vinyl sheet for making this, so it's a little bit some fluctuated noise in the signal. So I made this one, but it's broken because maybe due to some the connection or some the pressure of this sheet stuff. And however, for make it available, I did or Siberia came. I made some source code a little bit the tweak, like 共有で、そうか、ハードディング立ち上げなきゃいけない。そう難しいな。で、 これか。立ち上げて、キャンセルして、これか。そう。あれ、なんか違うやつだ。これじゃない、これじゃない。Sorry。共有停止して、もう一回これで、So this is sample source code for foot map controller, and in this code base, I use the almost same logic with you, which is one, but for settle the values that is fluctuated by some situation, I get measured in this example 10 times, and the calculate average for that value and compare it with the former 10 times average value and use it as a threshold to actuate the keys. So, but this is very simple logic, and maybe you can make very easy keyboard or mouse device in any software. So this is my example. So I will hand to Asuka-san. で、動画を出すにはこうで、
どっちからやろうかな。
こっち
姿勢の方。それ。
これを置いて、
はい。
で、画面を共有するときに、で、音声先出てなかったね。
音声を上げるのは、ここで上げればいいですかね。
音声いっぱい。
いっぱいあるんですね。
ここが静かになってる。
これは最大にした方がいい。Hi, I'm Natsuka. So I made two examples. So this is the first one. So when I'm at the office, sometimes it's hard to keep maintain good posture. So I made posture correcting chair. So this is a video. So when it's good posture, but when I will show again. So if the posture gets worse, the display's window will shut down. Here.
Sorry, I cannot see the video. It's all white.
Could you say it again? Sorry.
I cannot see the video.
なんだろう、音声がちっちゃい。
ビデオが見えません。
声が聞こえない。
真っ白で。
画面が見えないですか、もしや。
はい。ジンさんもいつオールホワイトって言ってる。
すいません。画面を共有しています。
画面を共有停止。で、こっち
です。
シェア。で、
How about now?
今見えて
Sorry. So I play it again, sorry. Could you understand what's happening here from the video?
Yeah, probably yes.
Yeah, so
I can understand.
so if the posture gets worse, the back will touch to the Q touch sensor on the chair, and the window I'm working on will be shut down. So I use the shortcut key to close the windows. It's with pressing Control key and press W on keyboard. So I put those code on the program. So this is my first one, and another one is これはい。いや、今日停止した。はい。So this one is the second one, singing leaf. This one is also very easy and simple program. And I used the characteristic of leaves that have conductivity. So I made the switch of leaf. So it's connecting to YouTube, and YouTube has shortcut key. So to play the music, it's to play the music, we should use pressing K key. So I write this on the program. So if you touch the leaves, it's play or pause. So this is my second one. And I was trying to do live demo here, but our lab, in our lab, there is no any leaves. So I made a little bit different one here. So, このまま下がる。これ抜いてもいいんで。映ってるか。
そこに立てなきゃいけないですか。
Can you see this cup and PC? This is a cup of water, and this is PC with YouTube. So I put this wire into the water. So this water should be switched to play or pause YouTube.
といった。
なんかちょうど見えてる。
これはYeah, that's all. Sorry, it's so easy.
多分マンションの電話で言っちゃった。ビデオだけです。
So when I'm developing this, there are many trouble because Q-touch sensor was pretty sensitive. So it moved when I didn't want to move. So yeah, it was hard. Thank you for listening.
I have a question about the Q-touch sensing.
Yes.
Question about how to use the Q-touch sensing. So, in case of the leaf, the singing leaf, it's very difficult to set the appropriate threshold. So, how to define or set or select the threshold in the program?
Sorry, I don't know what stretch hole is.
敷地1100センチ
Threshold.
敷地
Actually, I'm not sure. I didn't set any stretch hole for this program.
How much was the stretch
I-
for you?
I-
神谷さんのままだってことでしょ。
そのまま。
そうそうそう。
So I show
In
I see.
Natsuka-san's case, so it's the as Tamiya-san selected as a sample program. However, in my case, as I said, I measured the sometimes average and differentiate the value between that average. So the threshold is not absolute value in my program, but a relative value, like the 30 increase if that the value increased 30 from the before value. So that is actuated.
So in case of the Homer sound system, the average function is just for the calibration mode, or it is always running during the playing mode?
So it's always running in our
Always.
program. Yes. So in Arduino code, we have a loop function. And that is always running. That's always measuring the Q-touch sensor's value. Yeah, but you are right. It's very difficult to measure it.
Yeah.
So we need to tweak something for holding some general functions. I think. 石村さんの紹介します。So we have another case that Ishimura-san, who graduated this year. So she made a vegetable
oven.
音じゃない。This noise is caused by fluctuated value. So it's difficult.
So I think we have a video of the.
Oh, okay.
あ、できた。そこだとできる。ああ。
いろんな場所に置く必要が。
Oh, okay.
ビデオはいいですか？はい。So live video was successful, but I still want to show video, different song. Oh. So for the workshop, if you have any idea, you can program, of course, but you can tell us your idea with keyboard shortcut for any kind of application software in computer. So easiest one is, copy and paste keyboard. So many people are still making it. But if you may have a very different idea, so can you think about it? Maybe I give you, how long? 5 minutes? So after 5 minutes, if you have idea, please tell us.
Question about the Q-touch sensing. Okay.
Yes.
Q-touch sensing, is it just an on-off function, or is it possible to detect a kind of the analog? So, for example, if I touch the pad, just like homicide holding, gradually pushing the pad, and
Does it work? Gradually pushing.
静電容量としては変化します。微妙に。It has
but,
kind of
but using some kind of the threshold and detect on or off, it is impossible to simulate or detect the strength of the pressure, strength of the force. So
That is logically right, but it's very difficult to measure in actual sensing situation, I think, because
Okay.
the capacity response is a little bit very mixing of noise, and
Mhm.
sometimes it's very different from what you saw in last 1 second. So
Yeah, I see. Yeah, so maybe on off is safer to use. Yeah.
yeah.
And another question, can I ask about the Google Street View?
Yes.
So, like Tamiya-san, some people are making the cycling system using the Google Street View or Google Earth. And today, the example is using the clicking signal from whole sensor, just like the mouse clicking. And instead of that, is it possible to use the voltage analog signal corresponding to the speed of the pedaling, so that the street is smoothly moving in accordance with the motion of the cyclist?
I think the whole sensor just sensing one cycle. So this is one signal. So if you use the more and more, for my experience, the screen is not renewed, not so often. Even I pedal so hard, but refresh the screen is not responding so much.
Oh,
So you just pedal, just pedal that smoothly. So at the beginning, I use the arrow up key on the keyboard, same as the key, that kind of. I use the up arrow key for the for forwarding the street view, but it's very little. So I need to go fast. So I use I change the software as a mouse click. So I just point the mouse pointer a little bit far point of the screen. When I pedal, the screen go very maybe 5 or 10 times further than up arrow click.
Okay, thank you.
Yes. So it's 5 minutes. So if you have any idea, can you explain your idea?
Idea to make some project utilizing system. Yeah. I have some idea. Yeah.
Yeah, please explain. This is workshop.
I'm not sure it's interesting or not, but okay, let me check. There are some video or something.
How about Jim? Jim first. Any?
Tiny mobile phone.
Sorry, audio is not so good at that moment. Can you talk it later? So again, sorry.
Say I'm thinking of training mobile car. You control the car through the touch.
Sorry, control what?
You use the Q touch sensor as the controller to the mobile car, like a remote control.
Remote control. For what kind of software you supposed to use for the controller?
Arduino.
Huh? Control what?
Control the mobile car, like to
Mobile. No. Remote control. Okay. Like a game controller, right? You mean like this?
what's this?
Uh,
But it should have a like remote, like a remote control. You have 4 input and like control the car to move backward and
okay, thank you. So how about Oguri-san?
Okay. Let me share the screen. Just hold on.
Yes.
Screen share.
Oh.
森さんをクリックして、
クリックし
何です
て
かね。あ、今の黒。
シェアスクリーン。
共
共
同
同ホストにしなきゃいけない。で
あ
もそれでもいい。
Host disabled participant screen sharing.
Yes, just a moment. So you, yes.
Okay,
Yes.
okay. と、あ、そうか。これじゃダメなのか。まあいいや。ちょっと行きます。
はい。
これ去年のファーバーアカデミーのファイナルプロジェクトで。あ、今見えてます？
はい。
はい。
要は、これにつなげて世界を走りたい。
Oh.
だからこれの中身ってどうなってるかというと、
Is it possible to speak English?
Okay. Sorry, Jin-san. This is the video of my final project last year, Fab Academy 2020. And I want to connect this to the system the system what Tamiya-san introduced. So in this case, this system has a generator like this. Let me stop this one. Okay, so this is a so-called axial flux generator, and there are 1, 2, 3, 4, 8, 7 coils, and to utilize one of them, I can make the speed sensing. So by using this speed information in terms of the analog voltage, then maybe in this case, I controlled the speed of this small drive simulator. And now I want to control the Google Earth or Google Street View system. And actually, I tried to participate the Maker Fair Tokyo with this similar system, but this is a kind of the step machine system. So the generator system is located here, and by using these step combination, I can drive the generator and make some kind of the speed signal. And in this slide, in this presentation slide, I plan to make some kind of the gaming world, like flying over the forest, or some kind of the virtual world. But another idea is using the Tamiya-san system to go to the street with this system. This is some quick time. Yeah, this is some example of the movement of the system. So this is the stepper machine function. So there is a generator here, and this is a slider. So this sliding system, slider unit, is just similar to the final project last year. So by adding this step function, I can use this one as the stepper machine, like the just like the skateboard or snowboard. Yeah, this is my idea. Yeah.
Yeah, very nice.
So if I utilize directly use the Tamiya-san system, especially the software, maybe it's easier for me to put some magnet and Hall sensing, Hall sensor in the hardware. Yeah. Yeah, I'll try. Okay, thank you.
Can I ask question about your project? Oh, sorry, it's not related to Q-touch sensor, but I'm interested about your stepping electrode generator. How much electricity can you make by stepping?
Good question. In case of the my last year final project, it was about 20 watt, 20 watt. So not a very large amount of the electricity, but it's worth to charge the smartphone or something. But in case of the step machine type, it may be about 10 watt or something,
Okay.
maybe 10 watt. Yeah, it's my current target.
Okay. Thank you.
Mhm.
Is there any chance to experience your machine somewhere? Maker Faire?
Actually, my application for the Maker Faire was not accepted.
Oh,
So I'm not sure when I can complete my step machine type, but try to make it by this coming winter. Yeah.
so I'm looking forward to for
Thank you.
opportunity.
Thank you.
Now we have two people from Armenia. Hi,
Hi.
hi, Mariam. Bob King.
Hello.
Hello.
How are you both? Okay. Hi. How are you?
Fine. You?
Yes, good. What are you doing?
We have an electronics workshop now. Now we have a break.
Yes.
Okay,
It's
same
12,
time.
12:15
Yeah,
in
everybody's
Armenia.
busy, right?
We are having a break. It's
Okay.
12:15 in Armenia.
Okay.
What time is it in Japan?
At 5:50 5:50 p.m.
5:50.
Good morning.
Not a.m. p.m.
PM. Okay. Good evening.
Good evening.
I'll show you all of you from our Fab Lab.
Okay.
Arigato gozaimasu.
Right. Oh, this workshop is for English and Japanese, so you can speak Japanese also.
Daijobu.
Okay. So for my workshop, so this is almost finished.
小栗さん。小栗さん、I have a question to you.
Question. Okay.
So, in your slide, so I found a description about load cell sensor about your
Yes.
step machine.
Yeah.
And
yeah.
so I guess that means you you sense the weight of the behavior of the food and convert it to the speed of information from your explanation. But is it easily possible stuff to convert the weight information to speed information?
Actually, the speed is from the generator. In other words, the rotational speed,
Okay.
which means the speed of the movement of the legs. And the load cell is used for the balance detection, balancing. So just like the skateboard, it's like just like the Wii Fit. So the position of the center of the gravity controls the direction you are going.
Why don't you use the gyroscope stuff? 6-axis gyroscope.
Gyroscope.
the,
Gyroscope. Yeah.
Things.
Yeah, maybe just hold on.
Yeah.
Yeah, maybe it's a good idea. But the biggest reason why I'm going to use the load cell is because I have load cells. So I tried to make some kind of the weighing machine and trying to make just like the Wii Fit. So there are 4 load cells in this plate. And I thought that if I can utilize this system, I can control the direction of the movement in the Google Street View or the virtual world, just like the refit. So yeah, as Homa-san pointed out, using the gyro is one of the candidates. But as far as I know, my understanding is that gyro sensing system is the sensor detects the actual movement. So if the player moves largely like this, it can be detected. But in case of the load cell, the large motion is not required. So I think it is a kind of the difference between 2 systems. So maybe if there is some kind of the hinge or pivot, so that the board can be moved like this. In this case, gyro is better, probably. Yeah.
Okay. I understand. Thank you. So Neil said his project is the craziest project in PUB 2020. So
I understand.
craziness is still continuing.
Okay, thank you. So I want to share another one. It's maybe the last. So I try to make a drone controller. So there is the DJI flight simulator. So flight simulator has a keyboard shortcuts as a software. So I found these keys to control the simulator. So same as other projects, I use the shell, and shell is not shell does not have much keys as I want to. So I may make matrix, but it's only 12. So I try to use IO expander. So this is a I2C connection to make the increase the GPIO pins. It makes 16 pins from one secondary. So you can change the secondary address. So I think the 8 or something. So you can make we can add some buttons a lot. So this is a library I use for the expander. So this is the example of the joysticks to use the key. So this is a PCB. It's only pin headers. So this is the hardware. So I have 2 joysticks and some buttons and toggle switch, one toggle switch. So this is made here. So made by acrylic. So we laser cut at flat. We bend acrylic by heat. Actually, it's not me, him. And he also painted like this. So yeah. So inside of the, like this. So still tangled wire. It's okay so far. But it still needs some debugging, but basically, logically, it works. So I want to finish it later. So this is the whole program so far. It's a very similar to the function. I don't use the key touch in this controller, but the function is also same. So if you want to use other software with keyboard shortcuts, I think you can use, you can make any controller you want. Okay, thank you for participating in our workshop. Thank you for your time. Do you have any question?
I have one question about the bill of material.
Mm-hmm. Of what?
Yes, the material you listed are wrong. Like they're not this one, but the material for the workshop.
Workshop.
So, yes.
Yes.
Or can I share my screen?
Oh, sure. Yes, you can show. You can share your screen now.
Not this one. I'm sorry. This one, and I opened this link, and
sorry, this is yeah, this is not mine.
Not yours, but the link is
I found the wrong link at the beginning, so I asked the foundation to correct. Yeah.
Okay.
So now we
I
have
just
a.
want to point out.
Okay. Thank you. Yeah, that was confusing. So now we have only Charles BOM. I don't use it so much parts for this workshop. So thank you for pointing out.
And what are there any documentations we can like
Okay. So documentation. It's not latest is in my still in my computer. So I will update soon. So I'll give you URL of my site in chat. Okay. Any question? Any comment? Okay. Okay. So thank you very much today. See you next time.
Thank you.
Okay.
Thank you.
Thank you.
お
Bye.
疲れ様でした。
ありがとうございました。バイマリアン。
はい。
バイバイ。